Today I am going to explain about reciprocity theorem. Theorem statement. What is the reciprocity theorem says? It states that in any linear bilateral single source network, the ratio of input to output is constant even when their positions are interchanged. So the theorem states that in any linear bilateral single source network, the ratio of input to output, we can say in other way, the ratio of source to response. The ratio of source to response is constant even when their positions are interchanged. So this is explained here. So let's see here the first one. So this is a actual circuit case 1. So with the input voltage, the input is voltage here. So this is a network with the elements connected like this, and here the output is I1, current flowing in this branch. So the response is here I1. Then here the ratio of input to output is given by, in case 1, V by I1. Then if we interchange the positions of this input and output, so let us say that is case 2. So after interchanging the positions, both input and output, so here the input is V is here and the response is collected here in the input place. So let us say that the response is I2. The response is I2. So in this case, the ratio of input to output is V by I2. The ratio of input to output is V by I2. So V by I2. So according to the theorem statement, according to the reciprocity theorem statement, V by I1 is equal to V by I2. V by I1, that means the actual circuit. In the actual circuit, the ratio between input to output, and V by I1, that is, and after interchanging their positions, the ratio is given by V by I2. The ratio of input to output is given by V by I2. So in that case, V by I2. So according to the theorem, V by I1 is equal to V by I2. So that is how reciprocity theorem is explained. Now understand this theorem by solving a problem. So this is a problem for the given network. For the given network below, verify the reciprocity theorem. So here the input is V 10 volts and the resistances like this 1K, 3.3K and 2.2K. So here we verify this theorem, verify this circuit. Verify the reciprocity theorem. So for the actual circuit, first case. So we go for the first case, case 1. So actual circuit. Consider the actual circuit and the ratio and the showing the same circuit, given circuit as it is, and the response is collected here, this side, and where it is represented with I1. So for this circuit, we find the I1 value. Then we see what is a V by I1. So that is a case 1, right? So to find this I1 for the given circuit, by using the given values, circuit parameters and input voltage. So how to find this I1? We can do in different ways. We can solve this circuit in different ways. The method I have taken is here. I find the first total current in the circuit, the total current coming from the input voltage. Then using that input current, total current, I apply current division current division rule to find the current I1. So that is the current flowing in 3.3K resistor. So total, to find the total current, here I need to find the total resistance, total resistance, then I can find the total current IT. So the total resistance is given by the total resistance. Okay, so IT is equal to input voltage 10 by total resistance RT. So where total resistance RT is given by the resistance across the input voltage. So that is given by the parallel combination of these two resistors 2.2 and 2.2K and 3.3K in series with the 1K. So that is how RT is calculated. So 10 by that value, RT value 2.32 into 10 cube. So it gives the value of IT is 4.31 milliamperes. Then current I1 is given by I1 is given by, so because current here is IT, so according to current division rule, I1 is given by total current into opposite resistance by sum of the two resistances. So IT into the opposite resistance means 2.2 over 2.2 plus 3.3. So which gives the I1 value 1.724 milliamperes. So finally the ratio V by I1, the ratio V by I1 is equal to 10 by 1.724 milliamperes, which gives the milliamperes, which gives the 5.8 kilo ohms. 5.8 kilo ohms. So that is how. So that is how case one. In the case one, the ratio V by I1 input to output is calculated, which is 5.8 kilo ohms for this given circuit. Next, case 2, interchanging the positions. After interchanging the positions of input and output, so our source and response. So input voltage is taken here and finding the response current, finding the response in the voltage in the source place. So here we want to know the for this circuit current I2. Current I2. So how to find the current I2? So I'm using again current division principle by finding the total current coming from the input voltage. So that total current I have denoted with IT dash here. So um, so IT dash is equal to, so total voltage total voltage 10 over total resistance. What is the total resistance across this input voltage? Let us denote that RT dash. So 10 by what is the total resistance here? How to find the parallel combination of 1K and 2.2K in series with the 3.3K. So that is calculated. So 10 by 3.98 into 10 cube, that is the total resistance RT dash. So which gives IT dash value 2.507 milliamperes. 2.507 milliamperes. Now finding the current I2 using this IT dash is given by current division principle. So total current into opposite resistance by total resistance. So IT dash into what is the opposite resistance? 2.2. 2.2 divided by 1 plus 2.2. So that is what substituted. So by using the IT dash value. So I2 is given by 1.723 milliamperes. 1.723 milliamperes. That is a I2 value. So finally the ratio V by I2 is calculated. V by I2 is calculated 10 by 1.723 milliamperes, which gives 5.8 kilo ohms. 5.8 kilo ohms. That is a V by I2 ratio. That is a V by I2 ratio. So finally, we can see that V by I1 is equal to V2. V by I2 is proved. So for this given problem, that is how reciprocity theorem is verified. It is proved. Next one more problem. Verify the reciprocity theorem for the voltage V and current I in the network shown in figure. So verify the reciprocity theorem. So for the voltage V that is shown here and the current I that is also shown here flowing in this other side through the 2 ohm resistor, which is same as the other 2 ohm resistor also. So that is what it is mentioned, that verify the theorem for the voltage and current I, for the voltage V and current I. So now case 1. So first case 1. So actual circuit. So actual circuit. So taking the given actual circuit as it is, and the ratio of V by I. We want to know this I value. So same method like previous method. So find the total current here, total current IT here by using the total resistance of the circuit. So IT is given by 10 by RT. Let us say RT is here. RT is here. So RT is given by 2 plus 3 into 4 by 3 plus 4, right? So parallel combination of these two uh, in series with the 2 ohm, which gives the IT value. Then I1 is given, I is given by here, I is given by IT into 3 by 3 plus 4. So that is a I value. So finally now V by I is 10 by I value. So whatever we get here, so calculate the ratio. That is how finding the case 1 V by I ratio. Then case 2, interchanging the positions of source and response. So voltage 10 volts came this side, 10 volts, and current I come to input place. So I is here and no change in the position of the resistances. Only the input voltage, its position is came to this side, and finding the current in the source voltage place. So now how to find this I? So same method we can do, same like previously how we calculated. So 10 by RT dash, consider RT dash here. 10 by, so 4 plus 2 into 3 by 2 plus 3, parallel combination of this 2 and 3, parallel combination of this 2 and 3 in series with the 4 ohm. Then I value IT dash into 3 by 2 plus 3. So that is the I value. Then ratio, V by I ratio 10 by I. So we can see that we get the same ratio for both case 1 and case 2. So that is how for the case 2 also the ratio is calculated. Finally we can see that the ratio is constant. Okay, so that is how the ratio is constant for both cases, and reciprocity theorem is verified. That's all. This is all about the reciprocity theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.